These examples are going to be about non-uniform rods. So in the past we've looked at uniform rods where the idea is that the centre of mass is in the middle of the rod. So when we're drawing a force diagram, we draw the force, the weight of the rod, right in the centre. If non-uniform, that doesn't work anymore. And so the sort of questions we're going to be looking at, maybe finding where the centre of mass of the rod is, or it might be like the example we got here where we've got to work something else out and to do with it. So the example we have is Sam and Tamsin are sitting on a non-uniform plank AB of mass 25 kilograms and length 4 meters. The plank is pivoted at M, the midpoint of AB. The centre of mass of AB is at C, where AC is 1.8 meters. Well, I mean, first of all, that's really telling us that it's a non-uniform plank, so the centre of mass isn't in the middle. Sam has a mass of 35 kilograms. Tamsin has a mass of 25 kilograms and sits at A. Where must Sam sit for the plank to be horizontal? So the first thing you need to do for any mechanics question is draw a nice clear diagram of what is going on. So we have got a plank AB, which is 4 meters long. So this is going to be the plank. We've got a midpoint of M, so I'm labelling that here. We had also the point C, which we're told is 1.8 meters from A, so it must be this side of M. That's where the weight of the uniform rod is going to be acting. So let's draw that down here. We're told that it's got a mass of 25 kilograms, so the weight is 25g. Other forces we've got are going to be the weight of Tamsin and the weight of Sam. So Tamsin's the one who's at A, and her mass is 25 kilograms, so her weight is 25g. I'm labelling that on there. We don't know where Sam is. That's the whole point about the question, really. We must be somewhere on the other side to be balancing out the two other forces. So imagine it as though it's sat on a seesaw. So if Tamsin's sat on one end, Sam must be somewhere near the other one. So let's draw him on here. So his mass is 35 kilograms. And so let's label his weight 35g. And then there is one other force that's acting in this situation, which is going to be the reaction force at M. So let's label that on. Let's just call it R. Also want to put some of the distances on. So A to C, we're told, is 1.8 meters. So that's going on there as well. We don't know how far Sam is along the plank, but for sake of argument, let's say he's X meters from the middle. So this question is just a moments question. So we're not actually going to worry about working out what the reaction at the support is, because we can get an equation just involving x if we take moments about m. So that's what we're going to do. So taking moments about m, so I'm going to have a convention where we have clockwise moments is positive and anti-clockwise moments are negative. Could do it the other way around, it won't make any difference. So because we're taking moments about m, the idea is we're kind of fixing m in place and thinking what happens to the plank. So when Sam sits on the seesaw, if that was the only force, it'd be making the seesaw go downwards here. So that's really a clockwise direction, so that's going to be positive. Whereas the mass of the plank and the mass of Tamsin, well, they're going to be causing it to go the other way, so they're going to be negative when we work out these moments. And everything's nice and perpendicular here, so that's good. That just makes it easier. So we're going to find the total moment of all three of these forces. Note that the reaction force isn't going to come into it because that's going through M. So that's not going to cause the plank itself to turn. It's just pushing through the pivot, so it won't make any difference. So the moment for Sam's weight is going to be 35g times by x. The moment of the weight of the plank, 25g, which we have here, that's going to be minus 25g, because it's going the opposite direction, the rotation would be, and it's the distance 0.2 from the centre. The whole thing's 4, so to the middle's 2, that's 1.8, so we've got 0.2 left. And then similarly for Tamsin's, she's got a mass of 25 kilograms as well, so weight 25g times by the 2 meters that she is from the middle. All that's got to be equal to 0. So the idea is that the plank is supposed to be resting horizontally, and so for it to be horizontal, that means all the forces, all the moments as well, must cancel each other out. So we get this equation. And well, one thing we could do straight away, everything's in terms of g, so I'm just going to cross those out. They all cancel. And then I can make an equation for x. So I'm going to get 35x, take 25 times 0.2 is 5, 25 times 2 is 50. So in other words, 35x is equal to 55. So x is 55 over 35. And that comes to about 1.58 meters. That's to three significant figures, of course. And generally, we give decimal approximations in the examples in mechanics, though the mark schemes will allow if you left it as 55 over 35 as well, or equivalent to that. So the answer to the question then is that Sam is 1.58 meters from M. Or, I suppose we could also say, or to take 1.58, which is 0.42 meters from B. And that's it. That's then the answer to the question.